Good morning, everyone. Today, I start with a thought by Dr. APJ Abdul Kalam. If you salute your duty, you need not salute anybody. But if you pollute your duty, you have to salute everybody. So, as students, your duty is to study well, do your daily lessons, and if you do that duty, you will reach good heights, you will see good success in your life. So, welcome to another session on design of machine elements. Today we will see how to design a chain drive. In previous lectures we have seen design of flat belt and V belt, and when compared to the chain drive with other belt drives, we can see that there is a positive engagement between the chain and the sprockets. So there is a chain and the sprockets, and by which there will be positive drive or slip will be 0, so that it has high efficiency when compared to belt drives. So there is a chain and there is a sprocket. Now we'll see what are the other features of the chain drive. In the chain drive, the chains are made up of rigid links and they are hinged together in order to provide necessary flexibility for warping around the driving and the driven wheels, and these wheels are called the sprockets. The important terms in a chain drive is that the distance between two hinge points is denoted by pitch length. So these are the hinge points, and distance between hinge points is denoted by pitch, and a circle passing through all those pitch points is called the pitch circle. It's called the pitch circle. Then we have another different types of chains, in which first one is the bush roller chain, where there will be a bush and the roller which will be connected by a hinge pin, and this is a common type of chain which we use in our life. We can see such life in bicycles, in automobiles, bikes. Then advantage and disadvantages of chain drive or belt drive is that we have already said it is made of 0% slip. There is a positive drive, so there is no slip, so there is perfect velocity ratio is obtained, and they are made of metal. They occupy less space, high transmission efficiency because of low slip. There is no slip, so there has high transmission efficiency. Then it can be used for long as well as short distances, gives less load, transmit more power, high speed ratio, and it can operate under adverse temperatures because it is made of metal parts, so it can operate under high temperature also. However, its production cost will be relatively high and it requires accurate mounting, and chain drive has velocity fluctuations when it is unduly stretched, which makes much amount of noise in chain drives. Now we'll see how to design a chain drive. So this is our question. To actuate a power compressor from motor running at 1000 rpm, compressor speed is 350 rpm, minimum center distance is 500 mm, compressor operates 16 hours per day, and chain tension may be adjusted by shifting the motor on slides. So first step in the design is to find the number of teeth on the driving and the driven sprocket. So there is a compressor and a motor. They are connected by a chain drive. One represents the smaller pulley, 2 represents the larger pulley. Here motor runs at 1000 rpm, so this will be connected to the smaller pulley motor, and here we have the compressor. Motor speed is 1000 rpm and compressor speed is 350 rpm. Z1 is the number of teeth on motor and Z2 is the number of teeth on the compressor pulley. So from the table 14.36a in page 339, I can find the number of teeth on the smallest sprocket, or I can get Z1. So for velocity ratio or transmission ratio I equal to Z2 by Z1, Z2 by Z1 is same as N1 by N2. N1 is given as 1000 rpm divided by rpm of the larger pulley 350. You will get that value 2.85. So in this table I can see that it falls in this range 2 to 3, for which number of teeth on the smallest sprocket will be between 27 to 25. I can take a value in between that. Here I am taking Z1 equal to 25. So my value Z2 will be equal to Z1 into 2.85 equal to 71.4. Since I have to get a whole number, I will take it as next whole number equal to 72 teeth. This completes our first step to find the number of teeth, Z1 and Z2. Now we will find the pitch. You will remember, pitch is the distance between two adjacent axes of rollers. So in order to find the pitch, we have this equation. P should be less than or equal to this equation. P should be less than or equal to 10 raised to 10 into 60.67 whole by N1 whole raised to 2.3. All the values are known. N1 is the speed in RPS. You have to make sure that you put in RPS. Here N1 equal to speed of the smallest sprocket, that is 1000 rpm. So 1000 rpm divided by 60. When you substitute that value, P will be equal to N1 equal to 1000 by 60. 1000 by 60 equal to 16.67 rps. When you substitute this value, I will get pitch should be less than or equal to 23.67 mm. So this is the rational value. Now I have to standardize this value. So from the table I can get the standard pitch. So from page 340, table 14.39a, so 14.39a, I can get, I will check whichever value is just lower than 23.67. So pitch is given in the second column. So the nearest value which is just lower than 23.67 is 19.05, for which its chain number is 12B. So I will select ISO 12B, for which the braking load is also given 295059008850. These values are also needed for our calculations. So as of now we will take this pitch P equal to 19.05 as a standard value for this application. So I will select standard pitch P equal to 19.05 mm and the chain specification is ISO 12B. Now the next step is to find the pitch diameters, that is the diameter of the sprockets. So I can find the diameter using the equation 14.22n. D equal to P by sine 180 by Z. We already found the value of Z1 and Z2. Z1 equal to 25, Z2 equal to 72. I can substitute in this equation. So D1 equal to P by P equal to 19.05 divided by sine 180 by Z equal to Z1 equal to 25. I can get this value as 152 mm. Similarly, I can find the value of D2 also, substituting Z2 equal to 72, I can get D2 equal to 436.7 mm. So we have found the value of D1 and D2. Then we can find the center distance between the sprockets. So we have found the value of D1 and D2, diameter of the larger pulley, diameter of the smaller pulley, diameter of the larger pulley, and now we can find the center distance, that is C. C equal to P into Cp, where pitch is known. So we have this figure. So we have D2, D1, and the center distance is C. C equal to P into Cp, where P is the pitch, that is standard value 19.05 mm. Cp we can find from this range. I can take either 30 or 50 or take the mean value. Here I am taking the mean value, Cp equal to 40. So I will get C equal to 762 mm. Now we can find the chain length. We have in this equation 14.22k in page 301. Here most of the values are known. Cp is the value we have already found, 40. Then alpha is the value, pitch angle. Alpha can be found by sine inverse d2 minus d1 by 2c. So where d2 equal to, so I will write all those values, Cp equal to 40, d2 equal to 436.7 mm, d1 equal to 152 mm. Similarly, C equal to 762 mm. I will get alpha equal to sine inverse d2 minus d1 by 2c. I will get alpha equal to 10.8 degrees, and Z1 equal to 25, Z2 equal to 72. I can substitute all those values in this equation. I will get LP equal to length in pitches, LP equal to, so we substitute those values, Cp equal to 40, alpha equal to 10.8 degrees, Z1 equal to 25, Z2 equal to 72. After substitution, I will get LP equal to 129 pitch length. And we have already found this pitch length P. So what will be the actual length? 129 into pitch length. Okay. So chain length will be equal to pitch length into LP. So actual chain length will be equal to P equal to 19.05, and we have 129 pitch length. So L will be equal to 19.05 into 129, which comes around 2457 mm. Now we have to find number of strands in the chain. The strands can be either single stranded or simple stranded or multi-stranded. Multi-stranded means there will be 2 sets or 3 sets of chain, and is called double and triplex chains. So this is our equation, J equal to F by Fw from page 301, equation 14.22H. Here J equal to F by Fw, where F is the tangential force 1000 py/v, where power should be substituted in kilowatts and v is the velocity in meters per second. So I can substitute this value. F equal to 1000 P by V, where power should be substituted in kilowatts. Power should be substituted in kilowatts equal to, it is given, we have to transmit 15 kilowatts. And V is the velocity, V equal to pi dn by 60 for both smaller and the bigger sprocket. Velocity, tangential velocity will be same. If I take the smaller pulley, I can write V equal to pi into d1 equal to 152 mm, 0.152 d1 into its velocity 1000 rpm n by 60. That value will get as 7.95 meters per second. So velocity equal to 7.95 meters per second. After substitution, I will get 1000 into P equal to 15 divided by 7.95. This value I will get as 1884 Newton. This is the tangential force on the chain. Now we need to get the service factor. Service factor, it is given that we have to operate for 16 hours. So I will assume one among these working conditions. If I assume easy starting, smooth, steady load, it is greater than 10 hours. So I can take in this range 1.2 to 2. If I take a mean value, I can select Ks equal to 1.6. So I should assume, I should write this assumption. Assume easy starting, smooth steady load, from table. Our table number was table 14.35. Assume Ks equal to, I will take the mean value in 1 to 2, 1.2 to 2, so I will take 1.6. This is our factor for Ks. Now I can find J equal to F by Fw, where Fw equal to Fu by Fs into Ks, which is given in this equation. Fw equal to, we have this equation 14.22e, Fw equal to Fu by Fs into Ks, where Fu is the ultimate strength, Ks is the service factor, we have already found that value 1.6, and Fs is the factor of safety, which will be obtained from table 14.37. So how will you find Fw? So I have these two equations, J equal to F by Fw. We have already found the value of F equal to 1884 Newton. Now Fw equal to Fu by Fs into Ks, where Fs is the factor of safety, and Ks we have found from the table equal to 1.6, the mean value. Now I can write these two equations in terms of Fs as this one. Fs equal to J into Fu by F into Ks, where J represents the number of strands. J represents number of strands. Now I will get Fu, that is the braking load, from this table. Fu is the braking load. Fu should be in Newton, here it is given in kilograms. From this table we have selected 12B 19.05, for which if it is single standard, its value will be 2950. So if I assume J equal to 1, it means simple chain, J equal to 1. If it is duplex chain, J will be 2, and if it is triplex, J will be 3, and it goes like that. So if I assume J equal to 1, I can substitute in that equation Fs equal to J into Fu by F into Ks. So factor safety equal to, I will take this equation for our calculation. Fs equal to So I will rewrite that equation. Fs equal to J into Fu by F into Ks. If I assume simple chain J equal to 1, so J equal to 1, my value Fu will be equal to the breaking load for simple chain. For breaking load was 2950 kilograms. 2950 kilograms, or 2950 into 9.81 Newton. This is our value of Fu for J equal to 1. I will take that value into our equation. Fu will be equal to 2950 into 9.81, and we have already found the value of F equal to 1884 Newton, and Ks was found as 1.6. I will get factor safety equal to 9.7. Now we will check whether it is safe or not. From table 14.37, for 1000 RPM of the smaller sprocket, my minimum value should be, for 12 to 15 it is 11, 20 to 25 it is 12.9. My value as of now is 9.7. It is less than the required value 11 and 12.9. So it can be, I can write it is less than 12.9, so it is unsafe. So I cannot use a single chain for this application. So I have to increase the number of strands. So I will go for duplex chain. So what happens in a duplex chain? There will be two sets of chain. There will be one set, there is a two set, second set, so that there it can transmit more amount of load. And for duplex chain, it can transmit just twice the load. So my load will be, Fu will be equal to 5900 into 9.81 Newton. Taking that value for duplex chain in our equation, I will write this equation for J equal to 2 for duplex chain. J equal to 2, my factor safety will be equal to, I will just write the values. 2, there is a value of J, into Fs will be Fu will be equal to 5900 into 9.81. That's why the value of breaking load, Fu divided by F and Ks remain same, 1884. F into Ks equal to 1.6. I will get that value 19.87. So by using a duplex chain, I will get that factor safety equal to 19.87, which is higher than 12.9. So it is greater than the required value 12.9 and 11. So I can use duplex chain, double stranded chain. So my finding will be, I have to use ISO 12B 19.05 pitch duplex chain. This completes the design of chain ring. So in this step, in this video, we have seen how to find Z1 and Z2, how to find the pitch diameters D1 and D2, length of the chain, pitch, and how to select the chain from the table. Thank you for viewing. It's the season for corona. So in order to prevent from COVID-19 attack, wash your hands, maintain personal hygiene, and always cover your mouth and nose while coughing and sneezing. And this is a message from SCMS Group of Education Institutions. That's regarding your personal. And in order to have success in life, this is my medicine. Get to work. If you do it now, you can do it. If you postpone it, if you think that we can do it later, it becomes never. You won't do it. So if you want to have success in life, this is my mantra. Do it now. If you want to study, you study it now. If you want to learn AutoCAD, you study it now. If you want to learn swimming, you do it now. And prioritize your activities. If you have a wish to swim and if you want to learn, you have to prioritize your activities depending on what you want to be. If you want to be a good engineer, you should give preference for your studies, and you will win in your life. Thank you for listening. Have a great day.